Now that we better understand the difference between speed and velocity, we can look at some different combinations of them. A lot of times when we talk about speed, people are talking about an instantaneous speed or a continuous speed. So either of those work fine. Instantaneous speed, whenever you look at your car's dash and you look at what it is, that's your instant speed. That's how fast you're going just at that moment, right? If you put it on cruise control and you can stay at that, then we're talking about a continuous speed. So if you got it up to 30 miles an hour and you put it in cruise control, you would continuously go at 35 miles per hour. Notice I'm not giving you a direction, so we are talking about speeds here. It can be a velocity. There can be instantaneous velocity and instantaneous or continuous velocity. You just have to have the direction with it as well. So our third and final form is average speed or average velocity. And it tends to be a little bit more confusing than instantaneous or continuous because you would think an average, you know how to do an average. You take all the numbers in something and you add them together and then you divide them by the number of numbers you had, right? Well, you're not going to add together all your speeds and divide it by the number of speeds, instantaneous speeds, to get your average. You're looking at totals, okay? So totals means your total distance of the trip and then your total time that it took will give you your average speed. So let's say this is a car traveling in Chicago. It went through this windy road and the distance, notice, is 150 kilometers. So 150 kilometers traveled and it took them an hour and a half. So you do the math, divide kilometers by hours, and you get that it is 100 kilometers per hour. That is your average speed of the trip. Now, obviously, they didn't go 100 kilometers per hour the entire time. First of all, if you had started at 100 kilometers per hour, I don't think you would ever be able to get in the car. And then if you didn't slow it down before you stopped, you would smack into something. That's called wrecking. That's not called driving. Now, this works great for speed. You just take the total distance and divide it by the time. But it's a little different when we look at velocity. I'll show you that next. So to understand average velocity and how it differs from average speed, we're going to have to take a little bit of a look at a problem, because now with our average velocity, you're looking at the total displacement. Remember, displacement is different from distance. And so let's look at this problem. And I have this little scenario up here with an art gallery, a bakery, and a cafe. We're just going to say to the right is positive, or north is positive, and to the left is negative. South would be negative, okay? So we're going to start at the bakery, and it takes 30 minutes to get all the way, and so let's write that, 30 minutes. We'll write it in red so we can see it. 30 minutes to get back that way, right? And then it says that you go, it takes 1 hour to go all the way from that art gallery to the cafe. So we'll do that in yet another color. Now it's going to take us all the way that way in the positive direction, but it took, let's say, 60 minutes instead of 1 hour, okay? So if I was just doing this as a speed problem, an average speed problem, I could do that pretty easily. I would just add up all of my distance that I went, which was 2.5 kilometers. I went that, then I went that back, so that's 5 kilometers, and then 4, so that's 9, so I went 9 kilometers, and I would divide it by an hour and a half, so let's just put 1.5 hours for my total time, and I could get my average speed very easily. My average speed is, let's see, it goes 1, 2 to get 3, that'll happen 3 times, so it's 6 kilometers an hour is my speed, right? But we don't really want speed. We wanted our average, let's see if we can put it there, our average velocity. And remember, with velocity, we're concerned about direction. So we started at the bakery and we ended at the cafe, but we went backwards first. So first thing we did is we're going to need to look at that formula. Our V is equal to D over T, right? And now to get D, we're going to have to add all of those values together. Unfortunately, to get that D, it means we went a negative 2.5 kilometers plus a positive 2.5 kilometers plus 4 kilometers, right? Now, that means those two would cancel out, and my total displacement is only 4 kilometers from where I started. And if you look at this, you can see that pretty easy. See, if I started at the bakery and I ended up at the cafe, my total displacement is only 4 kilometers in the positive direction, which makes sense when we add all of those together. However, time doesn't have a negative value, so it's still going to be an hour and a half for that, which means I can now do my whole formula here. Now let's make it a little bit larger. I have it askew. There we go. All right, I can now do that formula. And here, I'll do it in blue. So I know that I had 4 kilometers in the positive and still 1.5 hours. Well, that's only going to take me, well, actually it's going to go 1, 2, and 2/3. So 2 and 2/3 kilometers an hour. Or if you know how to write that in decimals, that's 2.67 infinite kilometers an hour. So our velocity is much different than that speed. And these are averages. So our average velocity is much different from our average speed. Now, some of you might be saying, well, that velocity doesn't have a direction, but it does, because remember that this is a positive value, and we said that's north. So we could write that 2.67 kilometers per hour north, and that's why it's so much different. Hope that helps.